Okay, so let's back up. So the basic idea of closed is like the interval from 0 to 1 is closed. It includes its endpoints. You with me so far? Okay. If x is outside of t infinity, then x has to be some distance, right? That's the from t infinity. There's got to be some distance that I can separate it by. That's the basic idea. I need to think about that. I feel like I wrote that down wrong.
No.
Thanks. No, I didn't.
That sounds right. Makes sense.
Oh, sorry. This is not any point in t infinity. This is a limit point of t infinity. That's what makes it a limit point. Oh, good. And then I wrote it down backwards. All right, so if you have a limit point of t infinity, you should be able to find for any distance away at least one value that's not part of it, okay? Which works right here too. This is a limit point of the interval from 0 to 1. And if I pick any distance around it, it's got stuff in here that's not part of the interval. Right? That's what closed means. Questions?
Does it also mean that the members of the set is countable? You can actually count how many members there is?
Not necessarily. Good question. In fact, the Cantor set is uncountable.
Yay.
That's awesome. That's huge.
So you can't take the interval.
Well, actually,
Well,
it's not that simple. So what other sets do you know that are uncountable?
Real numbers.
The real numbers. And that is what makes the Cantor set so astounding. Is it's uncountable like the real numbers, and it's totally disconnected like the integers. Which is just, I hope your brain's going, huh? Because mine's still doing it. And I've been thinking about this for 20 years. All right.
I'm not going to sleep well tonight.
Questions? Anything else you want to know? I have some other things I can tell you, but that was sort of the stuff I wanted to make sure we talked through. Anything you want to talk about again? Talk.
never mind.
Okay.
I'm still not convinced that 1/4 is in.
I'm convinced, but I'm not sure I can convince you. Think about it for a few years. Tell me what you think. Some interesting extensions, if you're interested in fractal dimension, in fractals, and if you've seen fractal dimensions, the fractal dimension of the Cantor set. Yes. So if you haven't seen fractal dimensions before, we understand dimensions to be, right, 3-dimensional is 3 space, right? 2-dimensional is flat space, 1-dimensional is a line, okay? So this says that this dimension is somewhere between no dimensions, right, a point, and a line, which is another fascinating idea if you haven't thought of that before. So that's.
Where does the log? I know where the 2/3 comes from, but where does the log come from?
It's fundamentally has to do with this exponent issue. So, but it's a much bigger concept. We can have another talk on Hausdorff dimension if you want to. It's pretty cool stuff. But it's an interesting idea, at least if you haven't thought of having a dimension in between 0, 1, 2, 3, but there could
So
be
what kind of
such a thing.
shape does that form?
What shape does that form? It looks kind of like dust, a lot of dust. But there's no dust in this part. So, located dust. The other thing I wanted to just take your attention to, if you're interested in an extension, the what's called the fat Cantor Set. And we now live in the world of the internet, so I don't have to tell you much more. The fat Cantor Set is a really fascinating extension in that it changes some of these properties. And what they do is, instead of removing the middle 1/3, you remove the middle so that the amount you remove gets smaller each time. So first you remove the middle 1/4, and the next time you remove the middle 1/8, and the next time you remove the middle 16th, etc. So it's very, it's interesting. It changes the properties quite dramatically, even though you just tweaked the definition a little bit. I think that's what I have for you today, unless there's any further questions.
Is the dimension of the fat Cantor set different?
Yes.
Well, it's not, it wouldn't be disconnected anymore, would it, or is it?
I don't think it's disconnected
Yeah.
anymore. I think that's one of the things it gets is a little bit of, it's it's not disconnected because its measure's not 0. It's a little bit of length to it. Any other things? Thank you for coming.
Thank you.